Hey everybody, this is Mr. Bells here. This video is on 7-1. This is called direct and inverse variation. So what happens when one variable affects another variable in the same amount every single time? And it could be direct, that if one variable goes up, the other variable goes up. Good deal. Like as you buy more gas, you spend more money. Good deal. Or it could be as one variable goes up, the other variable goes down. That would be called inverse variation. I'll give you some examples of that. For instance, maybe you're talking about how much work you have to do around the house. So let's say you're painting a house. Well, the amount of time that it takes to paint a house probably varies inversely as the amount of people. So if you have more painters going up, you have more people doing the work, then the amount of time it should take should go down. Okay? So direct means they go in the same direction, either both up or both down. Inverse means that if one goes up, the other one goes down, or if one goes down, the other one goes up. Okay? So we're going to look at that, and there's no adding or subtracting or anything like that on it. So here's some of the things that I want us to be able to look at. So in this variation stuff, and this is going to lead us into some rational things, direct variation looks like this. Y equals k times x, and k is just some constant number. So like for instance, you guys know this formula, right? C equals 2 pi r, where the two variables are c, circumference of a circle, and r, the radius. And as the radius gets bigger, then the circumference gets bigger, or if the circumference gets bigger, the radius gets bigger. They go in the direct same relationship. They either both go up or both go down. Okay? Whereas this right over here is, again, inverse variation. And that would be, again, as x gets bigger, right, it happens. Does it make sense if it gets bigger in the denominator? Sorry. K is just some constant, some number, whatever it is. And I'll give you some examples as we go. As x gets bigger, y is going to get smaller. Or if x gets smaller, I'm dividing by a smaller and smaller number, then y is going to get bigger. Now, a problem like this right over here, this doesn't have direct or inverse variation. You'd think inverse because there's a variable on the bottom, and that's what we usually think about. But then there's this whole little shifty thing over here, this plus 5. Okay, so direct variation, there can't be any addition or subtraction. Inverse, no addition or subtraction, nothing like that when we're looking at these things. Okay, so numerically speaking, so I have some data. This variable, 1, 2, 3, 4, 5, this variable, 6, 12, 18, 24, 30, and I want to know if they vary directly or inversely, or maybe neither. Well, I think the obvious thing is, as the x's get bigger, the y's get bigger. So if they're both going in the same direction, then it could only be direct. But we have to do more than that. We have to check to make sure that the ratio of these things is the same every single time. So if I check this, this ratio is 1/6, 2/12 is also 1/6, 3/18 is also 1/6, 4/24 is also 1/6, and 5/30 is also 1/6. Now if we did that the other way around, and we did 6 divided by 1, and 12 divided by 2, and 18 divided by 3, and 24 divided by 4, and 30 divided by 5, we would get 6, right? And that just happens to be this equation, that y is equal to 6x. That's a direct relationship. So if I wanted to go here, I said, well, what happens if x is 12? Well, I know that they're going up directly. I know what the constant of variation is, the common number in there every time, and that's 6. So then this would be 72. Okay? Now this one, on the other hand, 1, 2, 3, 4, 5, 50, 25, 16. So as the x gets bigger, the y gets smaller. As the x gets bigger, the y gets smaller. So it doesn't mean that it has to be inverse. What we have to do is we have to check their products. Okay, so on inverse variation, the products of the two numbers are always the same. So if I multiply these together, I get 50. 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 So in that case, the product is the same every single time. So that means there must be an inverse variation relationship. And it just so happens to be that it's going to be y equals Remember, x is on the bottom. Whatever this product is happens to be our numerator. So the inverse relationship here is this, y equals 50 over x. And it might be that there are, x is the number of people at a party, and y is how many slices of pizza that you get, and 50 happen to be total number of slices of pizza. So if you take that 50 and you divide it by 10, everybody gets 5 slices. If there's less people, 50 divided by 5 is 10, you get more slices. Make sense? So if I had another set of data just like this, and I put 1, 2, 3, 4, and I put 2, 4, 8, 16, I said, hey, is this direct or inverse? You might automatically think it's direct because as the x gets bigger, the y gets bigger. But remember, we said we had to do the divisions. So let's check. This ratio is 1/2. This ratio is 1/2. This, that's 3/8. That's not 1/2. And this one is 4/16 or 1/4. So this is no. This is not a direct or inverse variation relationship. So just because as one goes up, the other one goes up, doesn't make it direct. The ratios have to be the same here. The products have to be the same here. So how does it work out when we do one of these actual problems? If we're dealing with some numbers and we learn some things. So if I have this statement right here, and I say the variables x and y vary inversely, that means that they're set up like this. Good deal? Inversely, other variable x in the denominator, y, the second variable. K is going to be some number on what it is, just like this was 50 slices of pizza, and you'll see some more as we go on. Okay? So it says if x equals 10 and y equals 2, x equals 10 and y equals 2, so I'm just going to simply write those in here. X equals 10, y equals 2. It says find y when x is equal to 4. So what you're going to have to do first is you're going to solve this statement to find out what my constant is. In this case, when I multiply by 10, I find out that my k is equal to 20, which means I now can write this new relationship, y is equal to 20 over x. Are we good on that? So now it says, again, so one more time, I use this information to find the k, I rewrite the equation with the k in it, and now I try and answer this part. So find y when x is equal to 4. So y is equal to 20 divided by 4, y equals 5. Check mark, that's my solution. Good deal? Now, let's try another one. This 3.5 says, still, quote, quote, the variables x and y vary inversely. That's what those imaginary quotes are. I just didn't write it out. So I'm going to go ahead and write it. Y equals k over x. Now it says if x is 1/4, when y is 30, so 30 is equal to k over 1/4, find x when y is 10. Well, I have to find out k first. Okay, so if I have division by 1/4, right? Division by 1/4, then I have to multiply by that same number to get it out, right? So another way that you could think of it is, I'll just do it like that. So I multiply by 1/4. So if this was a 2 here, I'd multiply by 2. So I'm going to multiply by 1/4. And it turns out that k, in this case, I believe, what is that, divided by 4, what, 7.5? K is equal to 7.5. So then my new equation must be y equals 7.5 over x. And this says find x, that's what we're trying to find this, when y is 10. So let's write it in there, 10 equals 7.5 over x. And this is kind of weird, right? I'm solving for the x, but the x in the denominator spot. So I need to write this one like a proportion, because I can't solve for x when it's downstairs. I got to move it upstairs. So when it's a proportion, I cross multiply, and I get 10 times x that way equals 7.5, and I divide by 10, and I divide by 10, and I get x equals 0.75. 0.75. Okay? Feeling okay on how to set those up? Now the only difference is if these equations said that the variables x and y vary directly, if it said directly, let me show you this right here, if it said directly, and it gave you that stuff, then I would write y equals k times x instead of k divided by x. And everything else stays the same. Okay, so the last part of this problem right here says the amount of time it takes to rake leaves at a park is inversely related to the number of workers. Awesome. So let's see if we can write that down. Amount of time it takes to rake leaves, so time is equal to, it's inversely related to the number of workers, and there's some constant. I don't know what that k is, but I'm going to try and solve for it. And it says if it takes 7 hours for 12 workers, so 7 equals k over 12. Solve for k. K is already upstairs, so I don't have to solve the proportion. I can just multiply by 12. K is equal to 84. Okay? So then T equals 84 over W becomes that problem. Does that make sense? And basically, I'm hoping you understand this, that this 84 represents the total number of hours it would take if there was only one worker, right? Time equals 84 divided by 1. If there's only one worker, it would take 84 hours. Dude, that's a long time. I'd want some friends there helping out. Okay, so now it says, how long would it take for 15 workers? So, one more time. I write the equation based on the relationship that it says, and it said inversely. I plug in the numbers that it gave me, 7 and 12, into the correct variables right here. I solve to find the constant of the variation, which is 84. I rewrite the equation with the 84 in it, and now I answer this question. How long for 15 workers? So 15 workers, that's 15 in the W spot. So the time equals 84 over 15. And you can see, if I do this, let me do it like that, 84 divided by 15, enter, I get 5.6 hours. Good deal. And hopefully that makes sense, because it took 7 hours for 12 workers. I now have more workers. It should take less amount of time. I'm going to show you a quick little picture of this on the graphs. So I'm going to go turn my stat plot off. That was left over from some geometry stuff. I'm going to go to y1, and I'm going to write y equals 5x. A graph. And you can see that's a direct relationship, right? So direct relationships are lines, and as the x goes up, the y goes up. Good deal? Or if I inserted a negative, I'd have that. So negative 5x. So as the x goes this way, right? It happens. Cool? Now, let's do it the other way around. Let's do what we just had, this 84 over that one. So y equals 84 divided by x. And this is going to freak you out a little bit. Oops, sorry, there's the thing. 84 divided by x. And when I graph that, look what happens. I got some weird looking stuff there. Well, the reason is this is a negative 10 to 10 window. So negative 10 workers to 10 workers and negative 10 hours to 10 hours. That doesn't make much sense. I need to zoom out 3, enter, and whoa, that's funkier, right? But you can see right here, as the number of workers increase, the amount of time gets smaller and smaller and smaller and smaller. Okay? And if I have less workers, I go this way, the time gets bigger and bigger and bigger. Now this thing over here doesn't really make any sense. I can't have negative amounts of workers and negative amounts of times. So this is the only reality to my problem. And if I go like this, second table, you can see as I scroll down this, 1 worker 84 hours, 2 workers 42 hours, 3 workers 28 hours, 4 workers 21 hours, 5 workers 16.8. And it just gives me all of the possibilities. And as I scroll down lower and lower and lower, you can see the more workers I have, the less time it takes to do this. However, it's never going to hit 0. There's always going to be something. I know that there's going to be one of you out there that's really smart and go, well, no, I bet you I could get it to hit 0. And the answer is, in reality, it will never hit 0. But yes, it'll show you a 0 here because it just can't go that many decimal places out. So if I went to my table setup and I had my table go by 250 and looked at that table again, you can see that this number is going to get smaller and smaller and smaller here as I go. You see that? Smaller and smaller and smaller. And I'm at 0.3 and 0.29 and 0.26s, right? And then I decide I'm going to have this actually go up by 5,000 because I don't want to wait that long. I look at my table. Now you can see that it's going to get smaller and smaller and smaller. And like this is 0.00005, right? So hopefully that was beneficial for you in terms of all this stuff. This is information on 7-1, direct and inverse variation equations. Please make sure that you give a good shot at the 7-1 homework for this data A. Talk to you later. Bye.